It's Unit 9. In this mini lesson, we are going to talk about probability. Probability is all around us every day. Whenever we turn the news on and we are, right now hearing about COVID every single day and the percentage of Americans that are at risk for COVID or getting very sick with COVID versus those that are maybe younger and healthier and not as likely to get sick from it. We're hearing about probabilities. When you look at the weather and you see it's a 50% chance of rain, it's a probability. And so we see it and hear about it every day. We use it to help us make decisions, and it kind of gives us a way to measure and assess uncertainties with various events in our lives. So the probability of something occurring is a number that represents how likely that event is to occur. And so probability is always going to be a number between 0 and 1 inclusive. So it can include 0 and it can include 1. If an event cannot happen, the probability is 0. If an event must happen, it's certain to happen, then we say the probability is 1 or 100%. So it can be those two extremes. And so, I was just thinking of some instances where we deal with or see probability in our everyday lives. We are curious about, what are the chances that mortgage rates are going to go up? What are the chances it's going to be a rainy day? What are the chances that we'd win the lottery? What are the chances someone at a party has the same birthday as you, right? So we do run into probability in lots of different ways. And we might not even realize that we are talking in terms of probability and risk. So there's three main types of probability that you will see in your lessons in IntelliPath this week. And so the first one is theoretical, and theoretical is more of a study of what should happen. So think of theory. In theory, right, we say that. In theory, what should happen based on equally likely outcomes. So theoretical is more of a study on what we think should happen. Empirical is based on what actually happened. And so that's based on trials or actually performing an experiment and marking down how many times a certain event takes place. Subjective is based on your personal experience or your judgment. It's kind of your intuition. And so it's not scientific like the other two. So let's start with subjective, just because this is the least scientific, right? This is just, like I said, more of an intuitive type of probability. You're basing it on maybe the past. And so subjective probability would be like when your child gets sick and you think, oh my gosh, he's running a fever. There's, definitely he's 99% chance he's waking up in the night. Or you study hard and you think, okay, I understand this material really well. I'm going to pass the test. So again, neither of these are scientific, right? There's no formal calculations. It's just reflecting your personal opinions and past experience. Theoretical is the result of considering all possible outcomes without actually performing an experiment. So just think in theory. That just means, we're looking at studies. We're saying, okay, if there's a certain number of outcomes that meet this criteria, whatever the criteria for the event is, and then we would take that out of our total number of possible outcomes, that's going to give us a theoretical approach. So if you think about, we're going to look at empirical here in a minute, but a lot of students get these two confused. And think that they should be the same. But a very simple example would be flipping a coin. So if we flip a coin, we know that in theory, our chances are 50-50, right? In theory, if I flip a coin, I have a 50% chance of landing on heads. So that's theoretical. We don't actually have to flip the coin to know that. We know that there's one outcome that meets heads, right? We've got heads or tails. So we've got two possible outcomes. And one of those, only one of them meets my criteria of being heads. So 1 out of 2 is the theoretical probability of flipping a coin and it landing on heads. 1 out of 2 is the same thing as 50%. Now, if I were to flip a coin 10 times, and now I'm talking about empirical probability, if I were to flip a coin 10 times, maybe 6 of the times it lands on heads. So maybe 6 out of 10 times it lands on heads. That's not 50%, that's 60%. So in my small number of trials, you could see that theoretical and empirical were not equivalent. So back to our theoretical probability examples and discussion. I have an example here that is talking about M&Ms. So a bag of M&Ms contains 6 colors: red, orange, yellow, green, blue, and brown. What is the probability of grabbing a blue M&M? So for theoretical probability, we'd say the probability of a certain event is equal to the number of outcomes that meet our criteria divided by the total number of outcomes. And so in this case, if we want to know the probability of grabbing a blue, if we had 6 different colors, right? And they're, the colors, we're going to assume that this bag has an equal number of reds and an equal number of orange and yellow and green and blue, right? So we're assuming that the probability of grabbing a blue would be, there's one color that meets our criteria, right, out of the total number of colors. So the probability of a blue M&M would be 1/6, or 1 out of the 6. What about the probability of grabbing a blue or a green M&M? So now it's a little bit different, because now we say, okay, well, what are the number of colors that are blue or green? So we've got 2 that meet our criteria out of the total number of colors, which would be 6. So 2 out of the 6, or if we reduce it down, we get 1/3. So empirical, remember, is actually performing an experiment. So it's based on observations or results of actual experiments. And so we still will use that kind of division of the outcome over the total number of trials. But here we're saying what actually happened, what did we actually observe out of the number of times we did the experiment. So here's an example. You have a die and you roll it 100 times and you mark down what the die lands on each time. Then you decide to calculate the empirical probability of rolling something smaller than a 6. So you look at your data and you see that when you rolled this die 100 times, 63 times out of the 100 rolls, you got something smaller than a 6. So I wrote this 2 ways. You could either think of it as probability less than a 6, or if it's easier for you to think of, you can think that means it's a probability that you landed on a 1, a 2, a 3, a 4, or a 5. So you looked at all the times you landed on one of those, and it was 63 times out of the 100. So 63 out of 100, or 0.63, or 63%. And so let me use a different color here. So really at this point, all I did was take, on my calculator, 63, and I divide it by 100, and you get 0.63. And we know that 0.63 is the decimal equivalent of 63%. So it's important to be able to go from fraction to decimal to percent and back and forth, because they all are different ways of representing a probability. Sorry, I'm trying to get off this straw. Okay. So here's my second example. In a recent poll concerning the age-old battle between Republicans and Democrats, 500 voters of a local community revealed to which party they belonged. 242 stated they were registered Republicans, 231 stated they were registered Democrats, and 27 were registered Independent. What is the probability that a randomly selected community member is a Democrat? So take a moment and try to read this again and see what you would come up with if you were calculating this empirical probability. So you have the data in front of you. You know, there's 500 total trials, right? Each person was a trial. And then you have the data of how many said Republican, how many said Democrat, how many said independent. So we're going to take the number of Democrats, which is 231, and we know we're going to take that and divide it by the total, which is 500. So 231 divided by 500, we get 0.46, which is the same thing as 46%. So 46% of this randomly selected community member, there's a 46% chance that a randomly selected community member is a Democrat. So I hope that this overview of probability in the real world, and the 3 different main types of probability that you will see in IntelliPath was helpful. Let me know if you have any questions about any of these examples or your work in IntelliPath. And you can reach out to me via Messenger or email. And if that doesn't work, we can meet live as well. Happy to do that. So I look forward to finishing our discussions on probability and risk, and I will talk to you soon.